Hey, welcome to Module 3. Now, Module 3, we're going to talk about processors. We talked briefly about them in Module 2, but we're going to dig a bit deeper into the processor itself. I spoke about how they mount into the motherboard and their relationship to the system, but now we're going to dig into what is it about these processors that make them so important? How do they work? What are the different types? So we're going to dig into that now. All right. We'll learn about Intel and AMD, and we'll talk about the different characteristics of the two. So let's jump over into MindTap, and we'll look at MindTap here for Chapter 3. Supporting processors and upgrading memory. So we'll focus on processors first. Now, when it comes to processors, it has within the processor, we have what's called an ALU. I'm getting all tongue-tied. I apologize for that. Arithmetic logic unit. And the ALU is where the work is done for the most part. Now, we've got in our processor, we've got this ALU, and we could potentially have more than one ALU in there, meaning that if we think about it like a small office, we could have more than one person working in that small office. I can have one person doing more than one task at a time. Those examples will fall into place when I talk about the different characteristics of processors. Okay, so let's go look at the different characteristics of a processor. First, we've got the processor speed. Now, the analogy I used was people working in a small office. Does everybody that you work with in your workplace work at the same pace? Are they as productive as each other? If you try to speed somebody up to work as fast as the person next to them, is it going to cause an issue where there be more errors? So there's the processor frequency. It's the speed at which the processor operates internally, how fast it can do what it's doing. Okay, that's measured in gigahertz. Okay, now aside from that, we've got lithography. Now the lithography, that's the average space between the transistors that are printed on the surface of that chip. Okay, the average space. So if you think about space relative to what we were talking about in Module 2, remember I said we had these buses. They're like highways. And the highways allow us to move stuff back and forth. The shorter the highway, the faster I can get things back and forth because it didn't take as long to get it there. So we've got the speed at which we can move down the highway and the length of the highway, along with how much traffic is on the highway. That will dictate how fast we get where we're going. Just like driving down 95 to get where we got to go to, the more people are on the highway, it tends to be slower pace. The less lanes we have, slower pace. So if I don't have to go as far, I'll get there quicker. Or a shorter period of time. I shouldn't say quicker. It'll just take me less time to get there. So the lithography is in nanometers. It's measured in nanometers. And that's the distance between those transistors that are printed on the surface of a silicon chip. So the shorter the measurement on that average, the faster the processor. So that analogy of the highways and the roads, distance on the road, should bring that into perspective. Now, we've also got the socket and the chip set that the processor can use. Socket is what that thing sits into. AMD and Intel are not the same socket necessarily. The chipsets that they're compatible with from one processor to another, even within AMD or Intel, may not be the same. Okay. So you need to know the sockets, the processor chips, or the chipsets that that processor is going to be associated with. The fourth feature is multi-processing abilities. Now, multi-processing is not just multi-processing, but it's also multi-threading. Okay. So multi-processing, what that means is I've got two people in the office. It's an analogy I used before. Multi-threading is any one given person in the office can perform more than one task at a given time. Now, the tasks, when it comes to the processor, are called threads. The system sends tasks to the processor to perform, and they are called threads. If you can handle two threads at a time, you are multi-threading. Okay. Intel calls its technology hyper-threading. AMD calls it hyper-transport. It's all the same thing. You're multitasking. You're doing more than one thing at a given point in time. Now, does that necessarily mean that you are actually doing two things at a time, or are you working on two projects at a time? That's the better way to look at it. The processor was given two projects to perform or to complete, and it doesn't mean that it's something that's going to take them a month to get done. It's just, I need you to go do this for me. And it may work on a couple of aspects of one thread and then pop back to the other thread. Now, these threads could have things to where the processor has to wait for something to come back or wait for another component to do something. So it's just like if you were trying to do two things at once. You can't be in two places at one time, but you can do two things at the same time. Now, multi-core processing means that I have what appears to be a single processor in the package. And in it, there is just a single core. Now, that same housing that it looks like just a normal processor could have more than one core in it, meaning there's other processors associated with it. Now, here's an example. Here's the footprint that we see that plugs into the socket. Within it, we have different CPUs built into the processor. In the past, a processor had one CPU in it. Now we've got a quad-core processor that can have 4 CPUs all working at the same time. 4 cores. Each core potentially working on 2 threads at a time. 8 tasks being performed at a given time. Okay. Excuse me. Not only can I have quad core, but I can have more than one processor mounted to the board. So I can have quad core in one and quad core in the other. It's a lot of processing taking place, a lot of power. But with that power comes heat. And that can be an issue. Okay? So we'll talk more about that in a little bit. Now, to be able to perform the tasks that it's got to perform, the processor is going to need memory. And that memory, we've got different levels of cache. Okay. And the memory on the processor die is called level 1 cache. It's not a lot of memory. We're only talking about 4 to 12 meg in L1 or level 1. Okay. Level 2 cache is memory in the processor package, but not on the processor die. Some processors use a third cache farther from the processor's core, and it's still in the package, but it's a little bit further away. Now, I used an analogy at one point about the configuration of a computer. And the motherboard's like an office space. The processor is the person doing the work. The hard disk is a file cabinet over in the corner. RAM is the short-term memory that's things that I want to use right here, right now. I don't want to have to get up and go far to get them. So it's things I use all the time. So they exist on my desk, and they're in volatile memory. That thing could fall over in the garbage at any point in time, and whatever's in it's lost. So I need to be saving a copy all the time to that long-term storage over in my file cabinet. The same thing holds true within the processor itself. Now, the processor itself is taking notes along the way and saving this L1 cache, L2 cache, L3 cache if it needs, depending on the configuration of the processor. Now, that cache allows it to not have to go find information that it's using all the time. Okay. Now, memory that is used in memory cache is static RAM, SRAM. Memory used on the motherboard, that short-term memory is dynamic RAM. SRAM's faster. DRAM is not. SRAM doesn't need to be refreshed all the time. Okay. Now, the processors themselves can process either 32 bits or 64 bits of data. Now, we talked about one CTS1150 class. That's the other exam for A+. That's the software side. And in that course, the first chapter, we're talking about the different operating systems. And the operating systems themselves have to be compatible with the processor and the motherboard. So if we're talking about a processor that's a 32-bit processor, it has to be compatible with the 32-bit chipset on the motherboard. So everything is compatible, and the OS has to be compatible for 32-bit. So all these things are tied together. If it's a 64-bit processor, then you've got a motherboard that's configured for 64 bits. The OS is 64 bits. Okay. We can go into system properties and look at what processor is in the system, how much RAM is there, the type of system we're using. So this is a Windows 10 system. It's Windows 10 Pro. It has an Intel processor. It's an i5 8600K. It's running 3.6 gigahertz. It's got 16 gig of RAM. How much is usable? How much is currently being used? It's a 64-bit OS. That tells you it's a 64-bit processor. X64 based processor. Okay. And that's just the basic configuration. It lets you know what's there on the board. How much RAM do we have to work with, and what operating system's there. Okay. So the processors themselves, I talked about it before in the last module, how the different ways they'll mount into the socket. Here's an example of an AMD. Okay. So the things you need to know when it comes to selecting and installing a processor: what socket do you have? Are we looking at 32-bit or 64-bit? Chipset that it's going to have to work with. Okay. So there's a step-by-step scenario you go through to pick a given chipset. Or pick a given processor for a given chipset. We've got, I talked before about the paste. I call it a thermal compound or thermal paste. And what it is, it kind of looks like toothpaste in a way. It has materials in it, not to make your teeth white or clean your teeth, but to allow for a transfer of heat from one surface to another. It's exactly what it does. So this would sit on top of a processor that would have the thermal paste, and then that will connect to or have contact with the processor. And the more surface area you have on these fins, the more heat can be removed. So this connects to the processor. The processor is getting hot. The heat transfers to these little fins. And then a fan would sit on top of this. And that fan would then draw air through these fins. Now we've got a couple types. One has a fan and one does not have a fan. And there's enough air running through the system to where you may not need a fan. It depends on the processor, depends on the system. Okay. There may be enough airflow in the system to where it doesn't need a fan on the heat sink or the heat exchanger. Okay. Now we talked about opening the socket and how you put the processor in and lock it down. We talked about that before, and the different types. Okay. The main thing is knowing that there are notches and that you'll line up the notches on the processor with the notches on the motherboard. It only goes in one way. Like I said, don't force it. Let it fall into place. You may need to shift it a little bit. Never do anything that puts force on those pins coming out of the bottom of the processor, the CPU. So here we've got it, notches aligned, it's fallen in place. We would then bring down that retainer and lock it in place. Here's an example of a heat sink with a fan mounted to it. this would sit on top of the processor and it would remove heat from the processor. Right? It's a heavy duty fan. Now, a laptop has a small fan built into it. Laptops cost more for a number of reasons. One, you would think it's smaller, so I'm not paying for as much equipment that's in there. Well, sadly enough, if it's smaller, that means that you're having to pay more because we need to do more to reduce the amount of heat in the system. That could be that it's got more gold in it, because gold transfers electricity and signals more efficiently than other connectors. So instead of using cheap connectors and generating heat, we'll use high quality, expensive connections that generate less heat. All we can do to generate less heat, we'll do, and ultimately that ends up costing us more money. Okay. Excuse me. So the heat sink on a processor is not the same as you would see on a traditional desktop system unit. Here's an example of how it's set up. And it's got this connection from the fan to the heatsink. Okay. And it's a step-by-step process to remove the processor, remove the heatsink. Now let's talk about RAM or memory. Traditionally in system units, you'll have four slots. You might have less on a smaller form factor or on a laptop. It's all about how much space you have in the motherboard to be able to add in these things. Now, we've got 2 empty blue slots, and then we've got 2 black slots. One is populated and one is empty. Okay. Now, some things that we're going to need to know. Common characteristics and purposes of RAM. And we've got DDR2, DDR3, DDR4, and SODIMM. Those 4 different technologies, you're going to have to know the ins and outs to them. Okay. Now, all the current motherboards for desktops use DIMM, dual inline memory module. Okay. Laptops use what we call SODIMM. And SODIMM has a smaller footprint. They're shorter. Right. So we've got different types of memory modules. There's a 288-pin DDR4 DIMM. Remember DIMM? Desktops. And then the other was SODIMM. It's not desktops. So these are DIMMs. It's desktop memory. They're longer. Notice in each one where their little gap is. So you see a row of connections, space, row of connections, row of connections, space, row of connections. Same thing here, row of connections, space, row of connections. These look similar, the top one, DDR4 and DDR2, but they are not. DDR4, 288 pin. DDR3 has 240 pin. So does DDR2. But the difference is the configuration of those pins. They're not the same. You can't just flip this thing around. It goes in a certain way. All right. So, knowing that each one has a different number or potential different number of pins, how much voltage it requires, can it support quad or dual channels? Right. So I've got a quad core processor, it's going to need to access memory. Can it do that if we're running DDR3? Right. So these are things that we'll need to know. And over time, we've gone from different types of memory. And if you want to go buy memory, let's talk about going to buy different memory. What do we need to know? Well, if you built your own system, you planned ahead and you thought about what you wanted to put in there. If you bought a canned system or an off-the-shelf system, HP, Dell, whatever it may be, you went online or you went to Best Buy, whatever, and you bought this system. It's a canned unit, or off-the-shelf, we'll call it. The manufacturer decided how it was going to be laid out. It's usually designed for a specific purpose, maybe small office, home, or educational. Depending on the use, it would have a different type of processor, amount of RAM, and different configuration on the motherboard. Now, they can set the maximum amount of RAM that system is capable to take. Or there may be a minimum amount of RAM you can take. Now, what RAM is currently in there, in part dictates what you can do. Now, that example we saw previously had 1 stick of RAM in there. Does it matter what that 1 stick is? Absolutely. Absolutely it matters what that 1 stick is. Because that 1 stick is interacting with the rest of the system. Does it matter if it's 32-bit or 64-bit? Yes, it does. Does it matter what slot it's going in? What is it? DDR2, 3, 4. Yep, that matters. So that's the number of pins. So the speed, number of pins, there's different factors that I don't want to get 2 different types of RAM for the same system. They need to be compatible and usually the exact same. Okay. So we've got different types of memory that we just talked about, DDR2, 3, and 4, how they differ. What's DDR? What's a SIM? That's older memory from back in the day. Okay, now the memory itself. Let's look at how this processor interacts with the memory that we've got. So we've got a memory controller. So let's say it's a 64-bit bus, 64-bit system. So my memory needs to be able to work on 64-bit. Processor's got to be 64-bit. The motherboard is a 64-bit bus motherboard. So all these things, it matters. Speed matters. So with that said, we've got the processor. It's communicating on that bus. We've got a memory controller. It's talking to the sticks of RAM. So we have channel 1 and channel 2. So we've got 64-bit channel 1 gray, 64-bit channel 1 black, channel 2 gray, channel 2 black. All right. Now, do we want to install them black and black or black and gray, keep them on the same channel or separate channels? All right. We want to match pairs of DIMMs on supporting dual channels. So here's an example. DIMMs in channel A slots and DIMMs in channel B slots. Come back, the gray slots are channel 1 and channel 2. The black slots are channel 1 and channel 2. They're on different channels. So the same channel would be the gray slots, same channel would be the black slots. Right. Why would I want, if I only had 2 sticks of RAM, would I want to put them both on the same channel? Well, I'm going to want to put them on different channels so that they're, well, let me back up. It's situational and it depends on the processor, but I'm traditionally going to want to put them not on the same channel, put one on channel 1 and one on channel 2. So I would traditionally put black slot, black slot. Right. And then if I added more, it'd be gray slot. Right. The way these things lock into place, there's a couple of different ways, but most of the time what you'll see is on the end of the stick of RAM will be a little notch cut out of it. It's on both ends. It only goes in one way. If you remember, this got a little notch in it. So it can only go in there one way. You'll match the notch to the little bar that crosses where you're going to slide it in. It's directional, so you will slide it straight down. Make sure it's not tilted in any way. You'll slide it straight down in, and as you slide it straight down in, these little clips at the ends will get drawn in and lock it in place. Okay. DIMMs have specific speeds. Speed matters, like we said before. DIMM also has an error checking technology called ECC, error correcting code. Now, it's not all the time, but one of the things that allows it to have that error correcting code allows us to check and make sure everything is the way this is supposed to be. I don't have any errors on my stick of RAM, on my RAM. Well, we've got software on hard drives that goes and checks for errors, but this is for the RAM itself. Okay. How do you upgrade memory? One, you need to know what you have, what the system configuration is, the speed, 32-bit, 64-bit, and how many bays you have open, how many slots you have open to insert RAM, what's there already. There's so many things I need to know. I've got a list of questions here. How much RAM do I need? How is it currently installed? What type of memory is currently there? How many and what kind of modules can I fit in? How do I select and purchase the right one for my upgrade? And how do I physically install the new modules? The biggest hurdle is finding out what's there and what the motherboard can work with or accept. From there are a number of different places to get memory from. How do you know which one to get? Read the reviews on them. How do you physically install it? I just talked about that. You'll slide it directly down in. I told you where to go look. We can go look at the system information. It'll tell us how much is there. I can literally go in and remove the stick that's there, and it'll have information on it. It'll say what it is. Make sure where you pull that original stick out, because you're going to want to put that back in if you're just adding one more stick that matches that one. Okay. So like I talked about, you can check the manufacturer's website to see what is in there, what you match it with, and there are different variety of resources you can go purchase memory from. I think I got the last stuff from Amazon. It was a good price, and it was here the next day. Okay, like I said, you will slide it back in. It's in the process of sliding this one in, and you see those clips as you push down will slide right in and lock into place. It takes very little force to slide this in. Like I said previously, do not try to put a great deal of pressure on anything related to these systems. Don't force them. All right. Laptop's a little bit different. Got screws that usually hold the cover in place. The chips don't mount in perpendicular like you would see in that previous example for a desktop. They're more perpendicular, or parallel, I mean. They're running alongside. So you literally slide that thing into the bay and push down as you're sliding it in, and it'll lock it in place. The tabs are here that lock it into place, similar to what we saw on the desktop memory. There's a little CMOS battery there. So here's an empty bay, and they're sliding this memory stick in. It's SODIMM. S-O, pronounced just like you're saying the word so, or S-E-W. It's shorter, similar in characteristics, and that there's a specific configuration. The slots in our little notch is in a certain place. There's a certain number of pins, and you'll slide that into place and lock it in there. Okay. So you see them going in at a slight angle. Align it with where the notch is, and as it's in place, you'll put a little bit of pressure pushing forward and pushing down, and it'll lock into place. Okay. So review. Go back over all you can when it comes to the different characteristics of processors and memory. Look at different systems and what you can see. How do they differ? Go and look at the configuration of a computer that you may have access to and see what processor it has. Is it 32-bit, 64-bit? What operating system? How much RAM? If you wanted to replace that RAM, go look and see how much it would cost, where you'd get it from. Not that you have to change it, but go look and see. Okay? So, ask questions early and often. We've got the assignment support form there for you. And I'll see you in the next module.